Okay, nomenclature. What a big word, right? This is what a lot of students are scared. Chemistry uses those big names. But nomenclature just means giving names. In this case, we are going to be talking about chemical nomenclature because we are going to be giving names to chemical. Okay? So any compound can be identified by both a formula and a name. Let me give you an example. H2O, water, they both represent the same thing. Obviously, you prefer the common name, but when you're writing equations, first it will be cumbersome to type the whole name. And second, you don't see what's going to happen in there. Okay? Using the chemical formulas is the only way that you can see what takes place in a chemical reaction, predict, and all of that. But you're going to have to be able to, given a name, write a formula, or given a formula, name it. Okay? So we are going to learn how to name ionic and molecular binary compounds. Binary compounds means that they are composed of two elements. Okay? Ionic compounds, some of them are going to have polyatomic ions, so those are not going to be binary. They're polyatomic means that you have to have more than two. And we're going to be talking a little bit about how to name acids. We are not going to talk about acids themselves. That's going to be a different chapter. But since we are naming things, we are going to learn to name acids too. This chart in here, I had it like since forever. I'm not going to insult your intelligence. You can print it if you want to. It's like a summary of everything we are going to discuss in this chapter. Okay? So if I was you, I'd print it out. If you have difficulty printing it out, if you're my student, I will be glad. There's a number of things that I can share with you, and this will be one of them. But basically, it just summarizes. So whenever you're labeling something, you can follow the flow chart. Okay? Notice that the first question is it an ionic or a covalent compound? Because the rules are different. You can tell they follow two different pathways. That's what I warned you in the previous video. So how do you know? Well, if it's ionic, you're going to have a metal and a non-metal. If it's covalent, you're going to have a non-metal and a non-metal. So whenever you're given a molecule, the first thing you need to do is figure out, and of course, polyatomic ions, that's going to be, it should be without saying, but I should know better than that. Okay? Whenever there's a polyatomic ion, an ion is going to form an ionic bond. That makes sense. Okay? So let's look at the rules. To begin with, you need to keep in mind that ionic compounds are going to be electrically neutral. Overall, you form ions, but you should have the same number of positive and negative charges. That means that the ratio of each ion is such that the number of positive charges equals the number of negative charges. And remember, these are not molecular formulas, these are crystals. They can be much bigger. What we're seeing here is the ratio of ions. So if you have aluminum +3 and oxygen -2, why is the molecule 2 aluminums and 3 oxygens? Because 2 aluminum +3 gives you 6 positive charges, 3 oxygens -2 gives you 6 negative charges, so that equals the number of charges. Please, 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 I don't know your instructor, but it drives me crazy. I have students who write, okay, 2, 3, and then -2. You do not put the charges when you run the molecule, okay? Now, what I do recommend students to do is say, okay, I hope sometimes this pen misbehaves. If I have aluminum +3, if I have 2, I have 6 positive charges. Oxygen -2, I need 3 of them to have 6 negative charges. But when I write this. I never put the charges in there. You do not put the charges in the formula. You can write it down before, especially at the beginning when you're learning to do it. But please don't put them in the final formula. How do we name them? Okay, we name the cation first. and then the anion. For the cation, if it's a monatomic cation, you just give the name, don't worry about it. But for the anion, you change the ending to IDE. So we already used this as an example of an ionic compound. This is sodium, the metal, and we do not change the name. This is chlorine, but we're going to change the N to chloride. Okay? Now, if one of them is a polyatomic ion, you do not change. I have, for instance, sodium, and people look at that and say that's sodium sulfide. Let me just simplify. Because they changed the ending to IDE. No, that's wrong. Sodium sulfide would look like this, only sulfur. That is sodium sulfide. This is a polyatomic ion. You don't remember? That was a sulfate. Oh, I know. It's sulfatide. No, 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 no. What did I tell you? You do not change the name. It's sodium sulfate. Do not change the name. Now, when you have several polyatomic ions, you put them in parentheses. Look at the example in here. You have two phosphates, so we put phosphate in parentheses to indicate that they behave as a unit. Some students refuse to put parentheses. Well, if you don't put parentheses, think about it. If I write PO42, it looks like I have 42 oxygens. That's not what I have in there. So that's wrong. Okay, let me try again. Calcium 3, PO4, 2. Well, first, this is not the rule. Second, good luck if you're typing with Word. You can put the subscript 4, but good luck trying to put that 2. You can't. And depending on your handwriting, if you're writing, people may or may not understand what you're trying to say. Most likely they won't. But when you write it the proper way, put phosphate in parentheses, that tells you that there's two phosphates. Now, if there's only one, if you have one polyatomic ion, you do not need to put parentheses. Okay? Let me give you an example. Sodium carbonate. There's only one carbonate. So there's no need to put a parenthesis. Really, if I was grading an exam, I said, this is wrong, this is wrong. If you put a parenthesis in the carbonate, I'm just going to laugh and say, oh, I just hope they don't tell anybody I was the chemistry instructor, but I'm not going to count it wrong. But you're going to learn very quickly that in chemistry, every time you have one of something, you just don't bother to indicate. Okay? Don't bother to put parentheses. You don't want people to look at you and say, where did you learn chemistry? So here you have examples. The basic idea is to show you from chlorine you get chloride, from bromine you get bromide, from oxygen you get oxide. So go through this. How do you name from phosphorus, phosphide? So it does give carbide as an unusual name from carbon. So just read over them so the names sound familiar. And notice again when you have polyatomic ions, acetate, ammonium, bicarbonate, they don't change. Okay? Now, what if the metal has a variable charge? Again, we're talking about the iron. You can have iron plus 2, iron plus 3. Now, if you have learned the old method, where you give it a different ending, forget it. The UPAC got rid of it a long time ago. Okay? We do what we just said before. You put in parentheses with Roman numerals the charge. You're familiar, iron 2 means iron plus 2, iron 3 means iron plus 3. The question is, okay, if they give me the formula, how do I know? Think about it. Chlorine, let's use iron chloride, iron 2 chloride. You know chlorine is -1, you have 2, so you have 2 negative charges. That means that the iron, to be electrically neutral, has to have 2 positive charges, so it's iron 2. Look at the one here at the bottom. The screen will let me write fluorine is -1. There's 4 of them, so you have 4 negative charges. That means that the tin has to have 4 positive charges. Look at that, tin 4. That's one thing that is very, very easy, okay? A different type of molecule is really we include in the ionic because we're talking about usually ionic compounds that hold on to water molecules, okay? You've heard about salt. Salt picks up water. That's why when you have a salt shaker on the table, you put grains of rice in there. One, because the rice absorbs the water. Two, because it helps break down because the salt solidifies. So a hydrate is a compound, usually an ionic compound, that contains a variable number of water molecules. Different hydrates have different numbers. Sometimes a hydrate of the same hydrate could have more than one number. That's one of my favorite tricks to play in the chemistry lab, because we do the determination of the formula of a hydrate, and I always tell the students, you better do the calculations, because if you Google it, you're going to find out that there is 2, 3, 4 possible answers. You want to just bet if you have 4 possible answers and you pick one, you have a 25% chance of being right. It's easy to do the calculations, isn't it? And get it right. Now, hydrates are very easy to remove the water just by heating gently. And whenever there's no water, that's called the anhydrous compound. So how do we name them? First, you name the anhydrous compound. Like in this particular case, you call it copper 2 sulfate. Now, do you look and say, okay, how many water molecules? Well, in this particular case, it has 5. So we call it pentahydrate. You put a prefix that tells how many water molecules. Okay? So you add the word hydrate with a Greek prefix that tells you how many water molecules. When you write the formula, please put a dot between the anhydrous molecule and the number of water molecules. Lots of students will write things like copper sulfate plus 5 water molecules. That doesn't tell you there's a bond between the copper sulfate and the water. That only tells you you're mixing copper sulfate and water, and you're going to get what? An aqueous solution of copper sulfate. The dot tells you that there's a bond between the copper sulfate and the water. Okay? So here you have the prefixes. You probably know most of them: mono, di, tri, tetra. At a certain point, you start saying, I don't remember. So that's why I gave you this table. In case there's some that you don't remember, you can look it up. So we get into molecular compounds. And once again, we are dealing with binary compounds. Remember, when you're sharing electrons, covalent bonding allows you for different ratios of the atoms. Remember the example we used in another video, H2O, H2O2, right? Water and hydrogen peroxide, different molecules. And because they're different molecules, they're going to have different properties. Water is necessary for life, hydrogen peroxide will kill you. That's it. So when you name the compound, you're going to have to indicate water ratio. With the ionic, you didn't have that problem because there was only one ratio that gave you a neutral molecule. But with covalent bonds, you can have different ratios. With ionic compounds, we name the metal first, then the non-metals. But here we have 2 non-metals. So we're going to name first the more metallic. And when we look at periodic properties, we didn't look at metallic character. So I'm just going to tell you here, an element is more metallic the farther you go to the left. The metals are to the left, so that makes sense. And also the farther you go towards the bottom of the periodic table. That's the one you name first. And you do not change the name, just like you did with the metals and ionic compounds. Now you put this one's going to be followed by the less. This is supposed to be the less, or the more non-metallic, sorry, or the less metallic. And this is, you're going to change it like they are 1 to I. Okay, so that's fine, but that still hydrogen oxide doesn't tell you if it's water or hydrogen peroxide. So you have to put prefixes telling you, and there are some prefixes that we just saw in there. You put the prefixes before. So this is going to be dihydrogen monoxide, telling you it has 2 hydrogens and 1 oxygen. This other one, dihydrogen dioxide. And by the way, years ago in church, an old lady came and she was passing a petition asking people to sign it. And she asked me to read it. I read it. They wanted to ban this awful chemical that could kill people, that you could find it in baby food, in baby juice. So it was a petition to Congress to ban dihydrogen monoxide. I had to make an effort to keep a straight face. She was a nice lady. And finally, when I got hold of myself, I told her, Miss Jeffcoat, that's water. Really? Yes, that's water. And yes, there is water in baby food. Yes, there is water in juice. Yes, water can kill you. If you drink too much, you ever heard about water poisoning? If you fall in the lake, you can drown. Then I found out that she was getting all those petitions, and every time she reached 100 petitions, she would send it to some group, and she had to pay $50 processing. So that's what they're doing. They're stealing your money. They're not going to send anything to Congress. Who's going to ban war? But every time I come here, I always remember that. One or two comments I need to make in here. When you have only one atom of the first element, you don't bother to put mono. But it has to be one atom of the first element. If it's the second element, you put it. You saw in there that hydrogen monoxide. But what if you have carbon monoxide? You don't say monocarbon monoxide, you just call it carbon monoxide. You don't bother to put mono when the first element has only one, but only that case. The other thing, when you have two vowels together, can you write it the way you pronounce it? If you have an A or an O, like I didn't write mono oxide, because when you read it, you say, what, monoxide? Okay, let's just write it the way you pronounce it. If you have 4 oxygens, I'm not going to write tetraoxide. I just condense it to tetroxide. Okay? Again, if you insist on putting the 2 vowels, people are going to smile, and nobody's going to criticize you, really. It's no big deal. So you have some examples, and you can see in there how when the first atom there's only one, you don't put the mono in there, but you make sure you put a prefix always for the second, and when the second one there's only one, then you have to put the mono, like we did with the water. So you have some of the names are condensed a little bit. So these are just some examples for you to look at. The last thing we're going to do is name acids. Okay? Like I said, this is not a lesson on acids. These are compounds that when you dissolve them in water, they release hydrogen ions. Okay? So we are going to change the name to indicate that property. For instance, you can have hydrogen chloride. Okay? This is a gas. But when you dissolve it in water, in an aqueous solution, it becomes an acid and has a different name. This is hydrochloric acid. So by using 2 different names, if I give you the name, you know if I'm talking about the gas or if I'm talking about the aqueous solution that's acidic. The gas is not acidic. Okay? The aqueous solution is. So it's important to know which one it is. So how do we do it? Remember, originally we call it hydrogen chloride. When you're referring to the acid, you change the word hydrogen with hydro. Instead of chloride, we're going to add ic. Instead of I, ic. So hydrochloric, and then we add acid because that's what it is. Okay? Very easy. Again, these are binary acids. You only have hydrogen and another element. And you have some examples in there giving you the pure compound versus the aqueous solution that's an acid. What if you have oxyacids? Well, oxyacids basically is an acid that contains a polyatomic oxygen-containing ion. Remember, we talked about oxyanions. Oxyanions can be bound to hydrogen and form an acid. So let's think of the sulfate. Okay? So when you add the, you call that hydrogen sulfate, but when you dissolve it in water, what do we do? It would be dihydrogen sulfate, or hydrogen sulfate. Sorry, don't put prefixes on ionic compounds. My fault. Hydrogen sulfate. So omit hydrogen. Okay? Then you get the root name that was sulfate, sorry, and add different endings. If the polyatomic ion ends in 8, you call ic. So that's going to be sulfuric. If you had H2SO3, the sulfide, we'll call it sulfurose. Okay? If it ends in 8, you change to that. And then add acid. Sulfuric acid, sulfurous acid. If you haven't memorized the oxyanions, you're going to have a hard time naming acids. So if you haven't done it, you need to get going. Okay? And you have some examples in there. You can look at them slowly. This is not complicated, but I understand that you need practice. Okay? I have a very long worksheet where sometimes I give you the formula and I ask you for the name. Sometimes I give you the name and I ask you for the formula. It's divided evenly between ionic and covalent compounds, so it's a very, very good practice. Okay? If you want to ask questions, you want to work one-on-one, you want a copy of my worksheet, go to the video description, find a link to my Wyson profile, and make an appointment, and we'll work together.